Yeah, servus. I think we all have one friend in common, and of course this friend is Node. When building web applications, we try to put something between Node and ourselves, and for most of us, this thing we put between Node and ourselves is Express, right? For me, what I put between Node and myself is Meteor, but Meteor does a lot more for me than just handle Node. My goal today is to show you what Meteor can do for you and to give you a basic understanding of Meteor's concepts. I've been working, developing with Meteor for about half a year now, and yeah, it's been really fun. For those of you who are more experienced with Meteor than I am, take what I have to say with a grain of salt. And for those of you who aren't, well, I'm just half a year ahead, right? Okay. So who is this Meteor guy? Well, Meteor is still in development, so I can't really tell you who Meteor is right now, but I can tell you who Meteor wants to be. And Meteor wants to be the best platform for writing almost any kind of web application. Meteor is developed by the Meteor development group, and as you can see, the Meteor development group, they really have high ambitions. To reach these ambitions, they've just received an $11 million funding from the Andreessen Horowitz, which is a group that also helped Twitter get started, and so it looks good for them, right? No matter what happens in the world, they can just keep on developing Meteor. Like Christoph said, I'm here today because this talk is actually part of my bachelor's thesis, and for my bachelor's thesis, I'm writing a classroom response system. Most of you probably don't know what a classroom response system is, so I'll cover this first and then we will get to Meteor. Classroom response systems are used in educational environments, like in universities. And typically when students come to a lecture, they are very passive. They just sit there and listen to the teacher. So it's like they're watching a movie. And the movie may be pretty bad if the teacher is boring, right? So Eric Masur, he started teaching in 1984 at Harvard. And he taught his class conventional by the classroom demonstrations until 1990. In those 6 years, he had 2 eye-opening experiences which led him to change the way he teaches his class. The first one was when he first started teaching, he would prepare notes for his students and he would hand the notes out at the end of each lecture. The students were like, well, can you please give us the notes at the beginning so we don't have to copy down everything? And Eric Masur said, sure, I can do that. And so the next time he taught the same class, he gave out the notes at the beginning. The unexpected result of this was that the students said, well, you're just lecturing straight out of your notes, so you're just reading what we can also read on our own. And we don't really gain any additional benefit from coming to the lecture. And Eric Masur was like, oh, the ungratefulness. I've spent so much time writing these notes, and I give them to my students all at once at the beginning of the semester, and now they think that I'm just reading my notes to them, right? But after all these frustrations, he realized, well, they actually do have a point, and they gain very little from coming to the lecture. So he thought about ways to use the lecture time more efficiently. Another moment which led him to change the way he teaches was when he read a paper by Haroon and Hastings, which states that students, they tend to be able to solve physical problems, like they are able to apply formulas and their problem-solving skills, but they don't really understand the concepts behind these physical topics. So when he heard about this, he was like, well, not my students. The evaluation of my course is good. My students are doing good on topics I consider hard. and so he was confident that his students would do good in these questions. So he gave them a test where the students had to answer a conceptual question, but there also was a conventional question where students just had to apply their problem-solving skills, like they've got the formulas, they insert the numbers, right? The left question is the conceptual one, where students had to guess how the intensity of the light bulbs changes if the switch S is closed. On the right-hand side, students had to actually calculate the currents in the 2 ohm resistor and some other things. There were 10 points for each of those questions. And on the conceptual question, students scored an average of 4.9 points. On the conventional question, they actually scored 6.9 points. So what this essentially says is they are doing better. They can calculate on these physical topics, but they really don't understand the concept behind this. So this led Eric Masur to change the way he teaches. We know from the first, from his first experience, he knew that he has to use the lecture time more efficiently, and that there really is no sense if he just reads the script to his students. So he explored various ways of teaching his class, and he came up with this. And the teaching method is called peer instruction, and there's this thing in peer instruction which is called a concept test. And the way it works is the students come prepared to his class, and Eric Masur would summarize the topic for about 20 minutes, and then he would pose a question to his audience. Each student would write down what he thinks the correct answer is, and Eric Masur collects the results, and depending on how many students were right, there are several outcomes, but we'll only cover the green case here. Like, if 30 till 80% got it correct, the students talk to each other for about 2 minutes, and then they answer the question again, and the results are collected once more, and then there are always more students who've got the correct answer. And the reason for this is because it's actually harder to change the mind of someone who is right for the right reasons than it is to change the mind of someone who is wrong. Okay, now you may be asking, well, wasn't this supposed to be about Meteor? And yes, it was, and we'll get there in a second, okay? So for those 2 points where you pose a question and then the audience votes and you collect the results, this is where classroom response systems are used, so they help you here. Okay, most of you will already know a system which is very much like a classroom response system, and this is on Who Wants to Be a Millionaire. If the candidate gets a really hard question, then if the candidate gets a really hard question, then he can ask the audience for help. And the audience has got these small devices, which are called clickers, and they've got buttons on them like A, B, C, and D. And then they just press this, and the result is shown to the host of the show and to the contestant. So sometimes these clickers, like these devices, they fail, and then there's a backup method where the audience has got cards under their seats and they just show what they would vote for. And this is actually how peer instruction worked at first. Now, in classroom response systems, we also use these clickers, but it turns out they have a few downsides. They are hard to maintain, they limit the types of questions you can ask, like you really can just have multiple choice questions, and they are expensive. I think 10 clickers are about 2,000 euros. So for my bachelor's thesis, I thought, well, there must be a better way to do this, and this is where Meteor comes in. So we have finally reached Meteor. Okay. This talk will not show you like the syntax of Meteor and what you have to do explicitly, what functions do what, but we will cover the concepts of Meteor. And I read on Stack Overflow, there was this comment which said, well, at its heart, Meteor is just a package manager, and you don't find this anywhere in the documentation, but this sums up Meteor the best, I think. The way the web worked for the last 10 to 15 years was this, like you have a database and it's really close to the CPU and they can talk a lot, and at the end they generate an HTML file, like a visual representation of your data, and then this is transported using HTTP to the client. So we essentially have a thin client architecture here. The way Meteor thinks the web should work, and the way the way development teams with huge budgets tend to write their applications, is they move the CPU to the client, so we essentially get the stick client architecture. And then the only thing that goes over the wire once the application is loaded is just data. But there isn't really a protocol for transporting the data, because HTTP is really bad for this. And it's bad for several reasons, because it's stateless, it's essentially unidirectional, it's unreliable. And this really isn't what you want. So good would be a protocol which is bidirectional, is only for data, is session-based, and doesn't care about what database you use and in which language you're programming. So Meteor is just the package managers, what we've already heard. And one of those packages is an implementation of the distributed data protocol. And this protocol is what they use to transport data from the client to the server and back. And we are entering Meteor at a really deep level here, but I think using the DD protocol is actually the best way to introduce someone to Meteor, because it turns out that all the other functionality of Meteor really relies on this distributed data protocol. So if you use other languages, or if the default approach for REST, for example, is you get snapshots of your data. So you have a client and you have a server, and the client asks the server about the data, and the server tells the client about it. And then the client has a snapshot of this data. But if the data on the server changes, then the client won't know about it. And with DDP, you get subscriptions. This means once this connection is established, there will be a cursor, and if any data changes on the server, then the client will get notified. And what goes best with this is that the client actually stores the data. So there's a client-side database here. And this is one of Meteor's packages. It's called MiniMongo, because it's a Mongo-side implementation of the Mongo. It's a Mongo driver for the client. And so you can search the database on the client. Now, if a client wants to change anything in Meteor, then he has to call the server changes the data, and it puts, it notifies the client about the changes. But because Meteor is isomorphic, so essentially the client and the server, they know the same code, the client can generate stubs for these methods, and it can immediately modify the local database. So we get stubs, and this is called latency compensation, because we immediately calculate the result, then we tell the server what we changed, and the server also calculates the results, and it tells us its results. And if there was any difference on the server-side calculation, those updates will get patched into our database. So there is a consistent state here, but for small amounts of times, maybe your local database differs from the one on the server. But you can't actually write, this isn't a security problem, because you only modify your local database. So we've got Meteor, and we are at a Node developer group here. and I want to explain to you where Node is used in Meteor. So Node is, like we've heard about these publications and subscriptions of the data which gets sent back and forth, and the thing that actually publishes this data on the server side is Node. And Meteor comes with a precompiled version of Node, so you don't even have to install Node yourself to write a Meteor application. And this Meteor runs Node. Node runs Meteor on the server side, but Meteor also runs on the client side. And it turns out that Meteor also has its own build pipeline, and we've heard that Meteor is just a list of packages. So one package can even hook into the build pipeline in Meteor. I've talked to a few people beforehand, and there are a lot of CoffeeScript developers here, right? And Meteor you can write a Meteor package, or there is a Meteor package which takes all the CoffeeScript files and converts them into JavaScript, so you can write CoffeeScript in Meteor. And this shows how mighty the packages in Meteor actually are. So we've seen, or I've told you that Meteor uses Node on the server side, but if you start a Meteor application, there are actually 3 servers that are starting. One is for static assets like files, then there is a database that starts, and this is usually Mongo, and there's Node. And Node uses DDP, which we just saw, to transfer data between the client and the server. And now I think it's time that I show you how a Meteor, or what a Meteor application looks like. Okay, to create a Meteor application, we simply type Meteor create, and then we enter a name. So Meteor actually also comes with a command line tool. Now this created a subfolder inside the current folder, and we can change into this. And if we look at the files, there are 3 files provided for you, and this is just a little hello world application. Now, if we start a Meteor server, we type Meteor run, but the run command is like the default one, so we can leave this off. Now the server started, and we can view it in our local browser. Yes. So you see that this is just a hello world application which has a little click handler. This is nothing special yet. So if we open this up, those are the 2 files that were that were created by default, and you can see that the HTML file is actually missing the HTML tag. So Meteor provides all of this for you, and you only have to fill in the important parts. You see that in the body tag we render the hello template, and the hello template is defined here, right? And this is handlebar syntax. We've got a greeting, which is a function, and the function is called on this side, is defined on this side. And if we change anything in the code, Meteor actually will refresh the whole every client that is currently connected. And if the client was typing into an input field at the moment, then Meteor will actually switch out all the code under the client. The new version will be what the client runs from then on, and its state will be preserved. So if he typed in 3 letters into an input box, the JavaScript changes right under him, and the new, and then what he did at the moment will be restored. So those 3 letters will still be in this input box. So this enables you for continuous deployment. We also see that we are checking whether we are running on the client or on the server here, because Meteor's code is isomorphic, so by default it runs on the client and on the server. And this is great for models, but there are cases where you kind of only want to run client-side code, or you want specific functions to be only on the server. But this is possible as well, and we'll look into this later. And to actually prove that this code is also run on the server, I'll just simply log this. And here you can see that the application restarted, and it actually did print this at the server. So now I've introduced you to classroom response systems before, and we'll now look at them at the application I developed. I will not start the application using the Meteor run command. I'll instead use this simple file, which will start a proxy server for the DDP protocol, so we can actually see what messages are transferred. Okay, now you can see the application reloading, and yes, this is basically the site I've been building, which we look at now. We've got this view of courses, so one teacher can have multiple courses where he can put in his questions. And we can search these courses, and this gives us back the local cursor, which monitors the changes between the client and the server. And to actually look for data on the client, we can use this fetch command, which gives us the course we are currently seeing, right? You could also update this course here or insert new courses into the collection, but I've disabled this for security reasons. I wrote my own implementation for this. Now we'll get to the real magic behind Meteor, which is when we bring in another client. So the client, which displays the Thursday group, is signed in as a teacher, and this group has a follower, right? And the follower is the client on the right side. And if I unsubscribe from this course, then you can see the teacher immediately updating. And this is because, well, we've heard that DDP monitors these changes, and then because Meteor is a reactive, because Meteor uses a reactive technique, the templates will change right then. So let's resubscribe. And this time we'll see what happens on DDP. So you can see that I called the subscribe method. This is like the remote procedure call. And this arrow is in the this arrow shows you who is talking to whom. So this is client to server, and then the server, he tells us that everything went okay, and he tells us about the changes because I'm now subscribed and the database has changed, and he will also tell the other client about the changes, which happens here. Okay. Now, when the teacher decides, or when the teacher wants to question his audience, he can start a session and publish the question to specific groups. and then once again it immediately changes on the other client, and I really didn't have to write any code for this. So if we go into the session, you can see why Meteor is the perfect fit for this. Because now imagine hundreds of students all connected and they're all on the same page, and the teacher displays a question to them, and they all see it immediately. They don't have to refresh, so it's really convenient for them. And then they can like answer it, and the teacher gets an indicator of how many students answered. And this goes on. And then the teacher can, first let's look at the results. Like you see that one person has voted for this. Now this is still in development and I didn't write any diagrams into this yet. So the teacher can display the next question. Once again, the students vote, and so on. Okay, you get the idea. Oh, one more thing. If you try to if you want to deploy your application, this is really simple with Meteor. All you have to do is you type Meteor deploy and then any domain name. And Meteor offers a free deployment for your applications, and they get this Meteor, a subdomain from Meteor. So I could deploy this to MNUG.meteor.com, and then it will bundle the application. It will shrink and uglify all the JavaScript files for you. It will, even if you have multiple JavaScript files, it will put all of them into one single file. So you save load time because you now only have one request, right? And so it really optimizes your application for you. And I could do this now, but we'll save the time. Okay. So let's take a look at what we've just seen. Well, we've seen 7 principles of Meteor. We've seen that you write the server and the client in one language, that once the application is loaded, the only thing that goes over the wire is data. We've seen that we've got client and server-side databases, and we've seen latency compensations using the stubs. We've seen that everything is reactive, and well, the last two, they're just they're just Meteor's slogans, or they're there for the good image, right? You embrace the ecosystem because Meteor has a lot of Meteor is organized in packages, and you can actually put out, for example, the reactive package and use this in your own website without caring about the rest of Meteor. Yeah. So I'll now give you some basic tips when writing Meteor applications. We've seen that Meteor runs code on the server and on the client, but it can also run on both because Meteor is isomorphic. And the Meteor really doesn't care about the way you structure your application. We've seen the Hello World application runs without any directories at all, but the ones that are here, the ones that have marks on the right, they control where your code runs, and the ones that have marks on the left, they have specific meanings for Meteor. Like Meteor lives in this Meteor folder you can see on the top, and the rest of them, they control loading order, or the tests folder files inside there are excluded from the deployment, right? Well, data and security, we've seen that the server can publish using the publish function, and it publishes subsets of the server-side data, and the client subscribe to this. Now, what's interesting here is that you see there's a query for the user ID, and so the published data really depends on who is authenticated. And Meteor comes with default authentication for Facebook and basically everything that implements OAuth 2. So this is just another view of what I've already told you about, where 2 clients subscribe to the server and they get different sets of the data. And if one client decides to update a file, then it, like this little arrow here shows that it can immediately modify the local cache, and then the updates get sent to the clients. Then we've got reactive programming inside Meteor, where there's if you have a reactive data source, which is what the session is, and there's a session that there's a reactive function outside of this, then if the reactive data source changes, your code will actually get rerun. So we stay subscribed to the current courses here without actually doing anything for this. And now you would think that the old subscription stays open, right? But because Meteor knows about the reactivity, it will tear down the old subscription and it will start the new one. We've already seen the packages inside Meteor, and yeah, you've got at the top here we see the Meteor file, and inside this, the Meteor folder, and inside this is a file called packages, and this file contains all the packages that are used in this Meteor application. And there are files here that have this little X beside them, and those are packages from the community. To get a package from the community, you have to use Atmosphere, where you can download packages for your Meteor application. So Meteor is essentially a package manager, but you can only manage, get packages that were from the Meteor development group. To get community written packages, you have to use Atmosphere. And there's a tool called Meteor, which allows you to do this very easily. And so why don't they just use the Node package manager? Well, because Node packages, they only run on the server, and Meteor packages are a lot mightier, and they may even hook into the build pipeline like we've seen with CoffeeScript. Now, finally, there's this tip from me, which is that you wrap your whole Meteor application into another Node, into a Node application. So essentially, you've got Meteor, which internally uses Node, and then you wrap everything into a Node application again. And this may sound confusing, but this gives you the advantage that you can use tools from the Node package manager to test your client-side code and to run to generate statistics about code complexity and such things, like we've seen here. So this is actually the Plato, which is a tool which does all this for you, and it shows that I've written almost 5,000 Java lines of code, and the average line length is 50. So wrapping everything in the Meteor application really gives you more options. Well, this was my talk about Meteor, and I hope you've learned something today. Thank you for listening. Do we have any questions?
So the isomorphic thing is very powerful, but I think there was some controversy about the security of it all. So basically, the client has full read-write access to the entire database to be fully isomorphic with the server, right? So how do you cope with that?
Okay, not all code in Meteor is actually isomorphic. You can have code that runs only on the server. We've seen the folder structure with the server directory, and you can put methods in there that the client can call to change data. And it isn't like you only publish subsets of your data. You don't publish the whole database to the client. So, and you control what sets of data you publish. Okay?
Yeah.
Okay. Any other questions?
Normally, these client-side applications, they use MVC. Is Meteor something in that direction too, in your view? Or?
Meteor uses MVVM, and well, on the client side it uses handlebars. So I think this is actually the concept, right? Okay.
So you mentioned DDP, but how does DDP work? Because you have to work over HTTP, so you need
right.
abstraction. Do you use comment? Do they use comment or something, or what do they use?
Actually, they want to use WebSockets, but WebSockets aren't that common amongst servers, so they amongst browsers. So they depend on sock.js, which does this for you. Like if there's WebSockets available, they use WebSockets, and if not, they use DDP over HTTP. Right? So they agree to the overhead that HTTP brings with it because it's just the simplest way to do it.
So if they use the HTTP connection, how do they push?
Well,
I mean, when there is a change on the database,
yeah,
it gets pushed out.
right.
How you open
This
the,
is what
HTTP from the other side?
this is what sock.js does for you.
So it polls.
It's a pull.
I don't really know about it. I'm sorry. You can look into sock.js.
WebSockets and comment. And then something like you ask the server every time again, something
So it's
changes
pulled.
for a long time in the socket.
So
These sockets.
Also for the communication, I didn't see any message IDs or whatever. So it's strict synchronous communication.
there are message IDs.
Well, I didn't see any handles for like this is message number 1, this is
Yes,
answer
it's
1,
in
this
there.
is message 2, answer
It's
2.
in there.
Okay. Didn't see
It's
it.
in there.
In the beginning, you mentioned that DDP is designed to be platform, language, and database agnostic. So far, everything I've read about Meteor always mentioned that they're using MongoDB on the server. Is MongoDB a necessity, or can you exchange it to another database?
Meteor is still in development, right? And you can use other databases, but you have to write, I think, a driver for it to actually work with Meteor. But they thought about it, and once Meteor 1.0 ships, they will look into other databases.
Okay.
So they've kept this in mind.
Thanks.
How well does this protocol work in like high latency and high traffic environments? I mean, there must be some kind of conflict resolution strategy if you say, well, I've got more or less synchronous communication, and I guess it works really well in low latency environments. Does it work as well in high latency environments?
Well, you stop what will get sent over DDP, so you immediately get this change in the client, and then whenever the server decides to answer, it will just patch these updates into your local database. So you get the changes immediately, and if the server comes up with something different, you will know about it later. There's a demo application here where you could create little circles using clicks, and then you could see that you could create circles, and then the server denied it, and the circles would disappear again.
Okay.
So for a short moment of time, you get something that really doesn't reflect the state that the server tells you about later.
Do you get information about latency?
I really don't get the question.
If we got a high saturation situation, yeah, you got a lot of changes on the database, and you add another change, it might take minutes to get the change back to you. Is there any information on the client side to detect such a gap?
I really don't know about it, I'm sorry. Do we have more time? Or?
Oh, if there are more questions.
Okay.
What happens when the server goes down? Is the client capable of running offline and storing all your, well, let's call it requests,
I think it does
send it to
this.
the server? Yeah.
I think it does this for short amounts of time, but once you've got too much going on, I don't know if this really works that well. So you can't really write offline applications using this.
So, if I may ask just another question, have you tried it on a mobile network? Because our experience with, especially with WebSocket connections on some network providers are not the best ones. I don't want to mention any names, but well, there are definitely differences between the various
The
providers.
application you've seen, I've already deployed it to the web, and I've been using it locally, and it's been working great. So,
And your students are then also using it from their phone.
right, but they are connected to the wireless
Yeah,
LAN,
wireless LAN,
and
yeah.
so
Yeah.
this really isn't a
Okay.
problem.
Last question?
I'm not sure what it's really offering on the client side. So it's kind of model that is used by your handlebar templates. And everything else you need to do in UI, you do using standard CSS and any UI
Yes.
magic library,
Yes.
more or less magic library, whatever.
Yes. It offers the part of Meteor like authentication and stuff. This is what gets sent to the client, and those are things that you can do on the client. But it doesn't really offer you anything for any default views or something.
Just have kind of model
Right.
you can work on.
Yes.
Thank you very much for this great presentation that you prepared, and for all of you who think Dominik should receive a good grade for this presentation, give him a nice round of applause.